Let's look at an example here of an ions in solution, specifically how we write a net ionic equation. This is really just going to be like a play-by-play of what the ions do in solution and how they interact and mix. So, ions in aqueous solution. Here's our question. If we were to combine or just take lead to nitrate, this S means it's a solid. We can think of it like this. Here's our lead. Now, because it's an ion, that 2 plus charge means it's lost 2 electrons. Originally, my lead would have been a rectangle. That would have been as an atom. But I've taken a pair of scissors and I've removed 2 chunks from the lead. Those 2 things I've removed represent the 2 electrons that lead has lost. Now, attached to this, I have 2 separate nitrate ions. Notice they each have a 1 negative charge, and that's because they've gained an electron. That's why they have this little thing sticking out on the side. So this molecule here would represent lead 2 nitrate. Okay, and it's a solid. If, though, I put this in water, because it is an ionic salt, it will dissociate or break apart into ions. And the way we write that is, generally we just write PbNO32AQ. The AQ refers to aqueous or dissolved in water. But what it means is that the lead is now separate from the 2 nitrates. And they're all floating around in solution. The way I could draw a picture of this, I would have the lead and the nitrates separate from each other. So in solution, these are all free-floating ions. They're not stuck together anymore. That term that we're using, dissociation, if you associate with people, you mix and you get together with them. If you disassociate yourself from someone, you pull away from them or move away. So dissociation is really the process of dissolving and ions breaking apart in solution. So let's look at another example. Sodium iodide. Sodium is a 1 plus, iodide is a 1 minus ion. Now, if I were to add sodium iodide to water, the sodium iodide will dissociate and break into ions, so it becomes dissolved in water. That's what the term aqueous means here. So I'll write that Na1 plus and I1 minus, and I can show that as 2 separate ions. Now what we're going to do is see what happens when you were to combine sodium iodide and lead 2 nitrate. So we'll mix them together and we'll write what's called an overall ionic equation, as well as discuss what are spectator ions, and finally write a net ionic equation. For this I'll need another sheet of paper, so let's go get a clean sheet here. So once I form these, the S right here refers that lead iodide was a solid, and the AQ refers to the sodium nitrate is aqueous. Solids do not break apart. They'll stay together in solution, but the sodium nitrate will break apart. The order doesn't matter. I could have written 2 sodiums and 2 nitrates, or 2 nitrates and 2 sodium. So once again, the order here does not matter. Now, we have a balanced chemical equation. I've added the 2 here because I had 2 sodiums at the beginning and the end. So if I'm looking at this, I had my lead 2 nitrate and my sodium iodide. There were 2 of them, and because these were aqueous, they have to dissociate or break apart. So at the beginning, all of this stuff was floating around. Now, what we formed here on the reaction, we formed a lead and 2 iodides came together, and this stayed a solid, so it stays together. And we were left with a sodium and a nitrate and a sodium and a nitrate, or 2 sodium nitrates floating around in solution. So this is what's happening at the level of the molecules in solution. So the lead iodide is a solid, another term for that is a precipitate, and the sodium nitrate is aqueous, or we'll say in solution. Now, we could write what's called an overall ionic equation. This shows everything as ions if they are ions in solution. Remember that when we started, the lead nitrate was aqueous as well as the sodium iodide. So writing this out, the lead nitrate was aqueous, so I'm showing them as separate ions. The sodium iodide was also aqueous as separate ions. The lead iodide is a solid, so it's going to stay together, and the sodium nitrate are going to continue to be aqueous. Now, what I notice is that I have what are called spectator ions on both sides of the equation. Spectators in sports basically just watch the action, and that's what spectator ions do here. They're not really the interesting part of the chemical reaction. So I notice that I have two nitrates on the reactant side, and I have two on the product side. Those would be called spectator ions, and we could basically ignore them. Do you see any other spectator ions? Good. I hope you said there's two sodiums on the reactant side and two sodiums on the product side. So if I were to ignore all of those ions, I'm getting rid of the spectator ions, and what I have left is what's called the net, that's what's left over, ionic equation. And I would write that Pb2 plus Aq plus 2I1 minus Aq yields Pbi2. So this is the net ionic equation for the reaction that we've shown at the very beginning. Okay, so that's how we got the AQ here. And PPT is just another way to write a solid. But PPT can only be used if the solid is formed on the reactant side of the equation. So I now have written out my equation, zinc nitrate aqueous plus barium hydroxide aqueous produce zinc hydroxide, a solid, and then I'm going to have barium and nitrate ions floating around in solution. Now, if I want to write an overall ionic equation, I'm going to have to dissociate my reactants as well. So we'll go ahead and do that here. It's a little bit messy. There we go. Zinc and nitrate are going to dissociate into ions. Barium and hydroxide will be ions because it says Aq after them. The zinc hydroxide is a solid, so it will stay a solid in our overall ionic equation. And the barium nitrate will dissociate. Do you remember what we do next to get a net ionic equation? That's right, we have to look for the spectator ions. So the spectator ions, again, are the things that appear on both the reactant and the product side. Can you tell me what are the spectator ions? I hope you identified nitrate as a spectator, as well as the bariums. So if I get rid of my spectator ions, I'm left with the net ionic equation. Zinc aqueous plus 2 hydroxides goes to zinc hydroxide. Good job.